Yes, okay, so we have the question from 2019 on purification of metals. So we have the extraction of iron, okay? So iron is extracted from its ores in the blast furnace. So this is an example of the blast furnace, okay? So you can see hot gases, there are waste gases there, hot air, and then we have molten slag, okay, and then we have molten iron. And then on top of the hot blast furnace, they put some charged materials. So we have coke, we have X, which is limestone, and then we have Y, which is hematite. Okay, so the examiner gave questions. Coke and material X are fed into the furnace. Okay, so A, name the materials X and Y. So what is X and Y? So we have to take note that X, we have limestone, and then we have also hematite. Okay, so if we see, we have X hematite, iron 3 oxide, and then we have limestone. Okay, so these are materials that are fed on the hot blast furnace. Okay, let's try to review back. Okay, so if we look at question B, what is the use of the waste gases? These waste gases, what are the uses? Okay, so the waste gases are used to heat the incoming air. Okay, so if we look at the incoming air, the waste gases are used to heat them. Okay, so we can say the waste gases, they are used to heat the incoming air. Okay, so that's one of the use of the waste gases. And then on the other question, we have C1. Okay, what is the reducing agent for this extraction? So the reducing agent, if we see, our reducing agent is carbon monoxide. Okay, so we use carbon monoxide for reduction. So this substance is said to be a reducing agent. It takes out oxygen from hematite. So it removes oxygen from hematite. Okay, and then hematite is said to be an oxidizing agent. Okay, so that is a topic as well. If you look at redox reactions, so in redox reaction, we have a reducing agent, and then also we have an oxidizing agent. So hematite is an oxidizing agent, carbon monoxide is a reducing agent. Okay, so take note of that. And then also we have this other question. Okay, describe how the reducing agent is produced. So the reducing agent is produced by, okay, so it is produced by reaction of coke and carbon dioxide. So when you get coke, you react it with carbon dioxide, then you form a reducing agent. Okay, and then they can ask you on D, what is the purpose of each of the following? The hot air. Okay, so this hot air. Now, the hot air has a function of it contains oxygen. Okay, it contains oxygen required for the reactions in the hot blast furnace, because in here there are some reaction that goes in. So it contains oxygen for the reaction of the reactions in the hot blast furnace. And then apart from that, hot air is used to decompose the limestone which is added in the on top of the hot blast furnace. Okay, so it is there to decompose the limestone. So here we can state hot air provide heat for decomposing calcium carbonate and oxygen for some reaction. Okay, so it provides oxygen for some reactions. So that's one of the uses. Okay, and then we can also see this other one, coke. What are the uses of coke? So coke, which is fed there, it is used for preparing the reducing agent. Okay, so we can use it for preparing the reducing agent. So we can say it is used for produce or prepare the reducing agent. So reducing agent is carbon monoxide. So we use coke to prepare the reducing agent. Okay, then also on the other side we have E, which is this question. Show a balanced equation in which iron is extracted from the ore. So the balanced equation should have, okay, so in our equation we should have iron, okay, iron 3 oxide, which is hematite, okay, which is a solid. Hematite is a solid. Okay, this is an O for iron. So this O for iron, okay, is added with a reducing agent, which is carbon monoxide. And then in the output there is the formation of pure iron, okay? So iron which flows out is in molten state, so it's a liquid. And then we have carbon dioxide. Now, where does the two oxygens come from? The two oxygens, or let me say, the three oxygens which are added to carbon dioxide, they come from hematite. So look at hematite. So here they are oxygens. These oxygens are removed by carbon monoxide. So this one is a reducing agent. So it takes off the oxygens from there. What will remain here on iron? It is iron, pure iron, which is in liquid state. And then carbon monoxide will acquire the oxygens, the three extra oxygens, and then the oxygens will be 6 in total. Okay, so this reaction, we call it a redox reaction. All right, so I'll make some more videos regarding purification of metals. Please, this topic is important, especially for this examination. Okay, this November examination, you have to study that topic seriously. So I'll make videos on extraction of zinc, then extraction of iron, and then alloys. Okay, so that you prepare effectively for the exam. Okay, so thank you for watching. Please consider subscribing to the channel, like the videos, and support the channel by sharing. Thank you.